Your heart just stopped. 1 second it was beating, 70 times a minute, the way it has every minute since before you were born. And now it isn't. No more pulse, no more pressure pushing blood up the long climb to your brain. From the outside, this is the moment a doctor would write down. Time of death, a number on a clipboard. But inside your skull, nothing has ended yet. In fact, something is just beginning. For most of medical history, we treated death as a switch, on, then off, alive, then not. The heart was the clock, and when the clock stopped, the person was gone, clean, simple, a line you cross once and never cross back. The problem is that the brain didn't get the message. It's worth sitting with how recent our confidence even is. For thousands of years, a stopped heart and stilled breath were the whole definition of death, and people were so wrong about the edges of it that they buried the living by mistake often enough to invent safety coffins with bells on the surface. Then came CPR, defibrillators, ventilators. Suddenly, hearts that stopped could be started again, and the old clock turned out to be far less final than anyone believed. We had to move the definition of death up into the brain itself. And the deeper we pushed that line, the stranger the territory around it became. Here's what's strange. Your brain is the single most energy-hungry organ you own. It's about 2% of your body weight, and it burns roughly 20% of your oxygen. It has almost no reserves of its own. The moment blood stops arriving, it has only seconds of fuel left in the tank. So you'd expect the dying brain to do the obvious thing: fade, dim, go quiet like a city losing power neighborhood by neighborhood until the whole grid goes black. For decades, that's exactly what scientists assumed was happening. No one had ever really watched. Why would you? You don't wire a dying person to a machine and wait. And then someone did. In 2013, a researcher named Borjigin at the University of Michigan was studying the brains of rats. The experiment wasn't even about death at first, but her team recorded electrical activity in 9 animals through the exact moment their heart stopped, and what they saw did not match the textbook at all. In the 30 seconds after cardiac arrest, the brains didn't go quiet, they erupted. A massive surge of high-frequency gamma waves, the kind of brain activity linked to focused attention, to vivid perception, to conscious awareness. Not less activity than waking life, more. Some signatures of consciousness spiked higher in death than they ever did while the animal was alive and breathing. Think about that for a second. The organ with no fuel left in the moment it should be shutting down, instead lights up like it's doing the most important work of its existence. The first reaction in the field was the obvious one: noise, a dying machine sputtering, random electrical garbage as the cells fail. That's the boring explanation, and the boring explanation is usually right. But this wasn't random. Random noise is chaos. It has no structure, no rhythm, no coordination across regions. What Borjigin's team measured was the opposite. The activity was organized. Different parts of the brain were talking to each other in synchronized patterns, the precise kind of long-distance coupling that, in a living brain, tends to show up during conscious experience. This wasn't a building collapsing. This looked like a building running one last deliberate program. And that raised a question nobody was ready for. If the dying brain produces the electrical fingerprint of consciousness, then the dying brain might be experiencing something. Not nothing, something. But these were rats. You can measure the waves. You can't ask the animal what, if anything, it felt. So for years, that was the wall the science kept hitting. And then, a decade later, in 2023, Borjigin's team published something they could no longer dismiss. Recordings from dying human patients, taken as life support was withdrawn, showing that same surge of organized gamma activity blooming in regions of the brain associated with conscious processing. The pattern had crossed the species line. It wasn't a quirk of rodents, it was happening in us. Then, in 2022, the picture got more personal still, by accident. A team led by neurosurgeon Ajmal Zamar published a case in the journal Frontiers in Aging Neuroscience. An 87-year-old man had been admitted after a fall with bleeding in his brain. Doctors connected him to continuous EEG to monitor for seizures. During that monitoring, his heart went into arrest and he died, which meant that for the first time, by pure chance, scientists had a recording of a human brain across the threshold of death. In the roughly 30 seconds before his heart stopped and the 30 seconds after, his brain produced a surge of the same rhythms, gamma, alpha, theta. And here is the detail that stops people cold. Those exact rhythms, in that exact combination, are the patterns the human brain generates during memory retrieval, during dreaming, during the act of replaying scenes of your own life. We have all heard the phrase, "Your life flashes before your eyes." For centuries, it was a saying, a piece of folklore, the sort of thing survivors reported and skeptics waved away. For the first time, there was a recording that didn't rule it out. It's one case. The researchers said so themselves, clearly and honestly. You cannot build a law of nature on a single dying man. The brain was injured. The conditions were far from clean. Science still can't tell you what he saw, or whether he saw anything at all. But laid beside the animal studies, beside the 2023 human recordings, and beside what came next, it stopped looking like a coincidence. Because the question was no longer just about brainwaves, it was about awareness, and there was already a body of evidence pointing at exactly that. In 2001, a Dutch cardiologist named Pim van Lommel published a study in The Lancet, not a fringe journal, one of the most respected in medicine. He and his team followed 344 patients who had been resuscitated from cardiac arrest across 10 hospitals. 18% of them reported some form of clear, structured experience during the window their hearts had stopped. Not vague fog, tunnels, light, a sense of leaving the body, a review of their own life. And critically, Van Lommel found these reports couldn't be explained away by low oxygen or medication alone, because the patients who had them and the patients who didn't had received the same drugs, the same oxygen levels, the same everything. Then came the case that haunts that study. A man was brought in deeply comatose, blue, clinically dead. During resuscitation, a nurse removed his dentures to manage his airway and set them in a drawer on the crash cart. The man survived. Days later, he saw that same nurse and told her, "You're the one who knows where my teeth are. You took them out and put them in that drawer." He described the room, the people, the cart. He had been, by every clinical measure, not there. His eyes were closed, his heart was not beating, and somehow he had carried a small, specific, verifiable detail back out of the dark with him. This is the work that Dr. Sam Parnia, a critical care physician at Southampton and later NYU, has spent his career trying to pin down. In his large multi-hospital AWARE studies, a striking fraction of cardiac arrest survivors reported some form of awareness during the time their bodies showed no pulse, no breathing, in many cases a flat brain reading. Parnia's term for it is careful and deliberately unsexy, not the afterlife, a recalled experience of death, a window lasting minutes in which the brain may keep generating experience after the heart has already quit. And the shutdown itself, it turns out, has an order. Consciousness and the higher brain don't simply blink off. As oxygen drains, awareness can persist while the body has already gone still and silent on the outside. Hearing is often described as the last sense to fade, which means the people who sit with the dying, the ones who lean in close and say the thing they need to say at the very end, they may not be talking to no one. So let's come back to that clipboard, that single line, time of death. What the science is quietly telling us is that the line isn't a line. It's a corridor. And inside that corridor, in those final 60 seconds, your brain may do something it has been preparing for your entire life without ever telling you. It may turn inward, Gather the gamma rhythms of deep attention and run, for one last time, the record of who you were. Here's the part that makes this impossible to keep at a distance. This isn't a story about rats in a lab, or one elderly man in a hospital bed, or strangers waking up on a gurney. The architecture is the same in every human skull. The same gamma machinery, the same memory circuits, the same hierarchy of senses switching off in the same order. The brain reading these words right now is carrying the instructions for its own final 60 seconds. You won't remember rehearsing it. You won't feel it loaded and waiting. But it's there, the way it's there in all of us, a closing program written into the oldest layers of what we are, set to run exactly once. And if hearing is really the last thing to go, then somewhere in your future is a final sound, a voice, a machine, rain on a window, the last piece of the outside world your brain will ever take in.